Good morning, students. I hope all of you have done exercise 3.2 from question number 1 to up to question number 6. Now next you see the question number 7. So in question number 7, two matrices are given, x and y. Actually we have to find out this x and y matrix. So for this one equation is given here, x plus y equal to this one you see 7025. And similarly another one is given, x minus y equal to this result. So what you have to do, we have to find out the value of x matrix and y matrix from here. So very simple, you have to put these to our equation 1 and 2 and then you have to add these two. If you add y cancel, so easily we can write this one twice x. So in the right hand side what we have to do, this first matrix and second matrix easily we can add. So if you add the result you get 10 0 to 8. And now how can we eliminate these two? So for this what you have to do, multiplying both sides by, because in case of matrix division is not possible, so that's why multiplying both sides by 1 by 2. So if you multiplying both sides by 1 by 2, so 1 by 2 2 cancel, so 1 by 2 into this. So in case of matrix, a scalar quantity we have to multiply with each and every matrix, so that's why 1 by 2 we have to multiply with each and every element. So ultimately we get here 5014. Is it clear? Similarly what you have to do, from equation 1 to, if you subtract these two, then x cancel, again we get twice y. In this way we can find out the value of y. So in this way, in question number 7, 8, 9, 10, 11, 12, all questions are same. So you can easily solve this type of questions. Is it clear? So I hope all of you have to do this all questions up to question number 12. Is it clear? Okay, now you see the question number 13 now. So in this case, a matrix given to you, which one is defined by fx. So fx equal to, here you see cos x minus sin x 0, sin x cos x 0, 0, 0, 1. So what is the order of this matrix? 3 by 3. So here 9 elements are there. So what we need to prove? We need to prove f of x, f of y equals to f of x plus y. Since you see the function fx equal to, we get all the result in terms of x. If in place of x, if we put y, f of y, if we put y, then here in place of x we have to put y. So that's why we have to write cos y minus sin y 0, sin y cos y 0, 0, 0, 1. Is it clear? Similarly, if it is not x, if it is not y, if in place of x and y, if it is given x plus y, then what you have to write? Cos remains same, in place of x we have to write x plus y, here minus sin x plus y, in this way you have to write. Now how can we prove this result? So f of x plus y, this result you get here. Now on the left hand side you see f of x into f of y. So you have to put f of x first matrix, then f of y, and after that what you have to do, with the help of matrix multiplication we have to multiply these two, and after that you get a result in terms of cos a plus b or sin a plus b. In this type of result you get. So from here if you put the formula there, and then you get this type of answer. So from here what we can say, left hand side equal to right hand side. Is it clear? Okay, next question number 15. You see here a square minus 5a plus 6i. We have to find out this result, and here only given matrix a equal to given what? 2 0 1 2 1 3 1 minus 1 0 of order 3 by 3. Now here we have to, first result is we have to find out a square. A square means what we can write? A dot a. So a matrix is already given 3 by 3. In place of a matrix you write 3 by 3. If you write 3 by 3 matrix here, 3 by 3 matrix here, so easily we can multiply with the help of matrix multiplication. We can multiply these two results, and then we get the value of a square. And after that what you have to do, next result you have to find out 5a. So 5a, how can you find out 5a? 5 is a scalar, so 5 into matrix A. So each and every element we have to multiply with 5, and then we get 5a result. Similarly you have to find out 6i. 6i equal to 6 into i. I means identity matrix. Identity matrix totally depend on the given matrix. So here the matrix is given of the order 3, so that's why we have to write identity matrix of order 3. If it is given 2 by 2, then we have to apply here 2 by 2 identity matrix. Is it clear? And then in this way we can identify the 6i value. After getting a square 5a and 6i, what you have to do, these three results you have to put here, and easily we can add or subtract the matrix, isn't it? And after adding or subtracting the matrix, you get a result, and which one is our required answer. Is it clear? Okay. So in this way you can solve the question number 14, 16, 17, 18. In this way you can solve, and if any problem you face, then you can ask me about these questions. So now next one is very important question here, question number 21 and 22. Is it clear? So now here you see, for question number 21 and 22, first of all some orders are given. If you see the order, X order is given 2 cross n, 2 by n, Y is given 3 by k, Z 2 by p, W n by 3, p by k. So after getting this order, now you see the question number 21. Question number 21 is given py plus wy will be defined. So when this result will be defined, we have to identify. Is it clear? So now py plus wy, when this result, this function or multiplication, this matrix is defined actually. So first of all you see the order of p order is already given p cross k, so that's why we write here, you see. Similarly p into y is given 3 cross k. Now if you see this part, p into y, these two are in multiplication form. So when the matrix multiplication is defined, when the number of columns of the first matrix and the number of the rows of the second matrix equal, then the multiplication is defined. So for that reason here the k value and 3 value must be equal. That means k is equal to 3, then their multiplication is possible. Is it clear? Is it clear? So that's why when k equal to 3, that means when k equal to 3, and after that from here multiplication, what order we get here? Number of row is here p, number of column k. So that's why the order remain here p cross k. Is it clear? So that's why we write p by k. So when k equal to 3, if k equal to 3, then only the multiplication is here defined. Is it clear? Okay. In the next part you see w into y. Similarly here again we have to identify the number of columns. Here 3, here number of rows 3. So that means here matrix multiplication is possible. So if matrix multiplication is possible, then the order will we get here n by k. So that's why we write n by k. Is it clear? Okay, now after getting these two, now here the order is p by k, and here the order is n by k, and here it is plus. So in case of addition, order must be same. We know this condition. So if order must be same, so here k is same, and what we get, p must be equal with n, because order required here same. So p must be equal with n, then the addition is possible. Is it clear? I hope all of you understood this one. So only two conditions we get here. First condition is if k equal to 3, and the second condition is p equal to n. If these two conditions we get here, then this result is defined. So that's why from this condition the option is A. Is it clear? Okay. Now in the second question. Now in the second question, the condition is given if n equals to p, n is equal to p, then what is the order of this 7x minus 5z? So 7 is a scalar, no problem. 5 is a scalar, no problem. So just we need the order of x. The x order is 2 cross n. So that's why we write 2 by n. What is the order of z? Z order is 2 by p. So here subtraction, for addition or subtraction we know the order must be same. So here 2 cross n equal to 2 cross p. That means 2 is same here, n must be equal with p. So from here two orders are we get, either if n equal to p, then we get either 2 cross n or 2 cross p. So if 2 cross n or 2 cross p we get, then anyone if we get, then our answer is complete, because here division order must be same. So that's why n equals to p. So from here what we can say, which option is given in your book? The order is given 2 cross n. So that's why the option is B. Is it clear? Okay. Now next topic is transpose of a matrix. transpose of a matrix. So actually what is the meaning of a transpose of a matrix? From this example we can understand very easily. So suppose we consider a matrix. Matrix may be square matrix, rectangular matrix, any matrix you can consider. So here we consider a matrix of order 3 by 2. 3 by 2 means number of rows 3, number of columns 2. You see here A, B, C, D, E, F. Is it clear? So now we need the transpose of this result, and transpose is defined by A dash, you see here, or A small letter t, or A capital letter T. Any one symbol we can use. Generally here we use this dash symbol. So A dash. A is a matrix, we need the transpose A dash. So A dash, how can we identify? Transpose means what? We have to exchange the number of rows to number of columns and number of columns to number of rows. As you is what you have to do. What you can do here, we say AB. AB is the first row, so we can write this one in first column. So that's why AB. Similarly, CD is the second row, so we write in second column. EF third column. Is it clear? Or you can convert this one from column to row also. So the first column is what? A, C, E. So here we write in first row A, C, E. Similarly, the second column is B, D, F. So that's why we write in second row B, D, F. Is it clear? So the transpose of a matrix means what? The interchanging of rows and columns. Simply we can say the interchanging of rows and columns, and which one is defined by A dash, A, T, or capital letter T. Is it clear? Okay, next we move to properties. So now here the first properties you see here, A transpose transpose. That means a matrix is given to you, you have to transpose one time, and again if you transpose the result, then again the same matrix you get here. A transpose transpose equals to A. For example, you see here, if we consider matrix A of order 2 by 2, so that means 1, 2, 3, 4. If you transpose this result, so obviously the first row is 1, 2, so that's why first column we write 1, 2, 3, 4. Again, if you transpose this result, again if you transpose, then first row 1, 3, so that's why we write 1, 3. Second row 2, 4, that's why we write second column 2, 4. So if you see here this result 1, 2, 3, 4, 1, 2, 3, 4, these two results are same. So from here what we can say? A transpose transpose equal to the matrix itself. Is it clear? So in this way, if you see the second property is here K A transpose. K is a scalar here. Remember, K is what? A scalar. So if any scalar, if you multiply with matrix and then if you transpose, then the result will be, we get like in this way, scalar into A transpose. That means this scalar not affecting the matrix. Is it clear? So Ka transpose or Ka transpose meaning is same. Similarly, if you see for this one, for addition A plus B whole transpose, this one we can write A transpose B transpose. That means if you add two matrix and then if you transpose, and separately if you first find out the transpose and then you add the result, we get same. Similarly here you see AB transpose equal to B transpose A transpose. So now this one is very important, because you see here A B transpose, and here the result we get B transpose A transpose. One thing you remember here, AB whole transpose is not equal with A transpose B transpose. Is it clear? So for this proofs here, first one already you have done. For 2, 3, 4 you can see the example 20 and 21, then very easily you can understand this three property. Is it clear? Okay, now next your task is what? Homework exercise 3.3. So in exercise 3.3, from question number 1 to question number 5, easily, I think easily you can solve. So your task is what? You have to complete this question number 1 to question number 5. These questions are you have to complete in your homework copy, because if you do this practice, then if any questions are arise there, then you can ask me very easily. Is it clear? So your task is from question number 1 to question number 5 you have to solve, and with this the example 20, 21 also you have to do. Is it clear? Okay, in our next class we discuss about symmetric and skew symmetric matrices. These two are very important. In our next class we have to discuss these two, skew symmetric matrices and symmetric matrices. Is it clear? Okay, thank you.